Okay, for our third part of today's lesson, we're going to look at what happens when we've got a denominator that's got a rational part and a surd part, so basically a binomial in our denominator. And a clue to how we would deal with this we sort of dealt with in the previous lesson. So if you remember in the previous lesson, I showed you this relationship here. So when I've got two things in brackets that are exactly the same, but the only difference between the two sets of brackets is that we've gone from a plus sign to a minus sign, or a minus sign to a plus sign, we end up with this situation where that's going to work out to be that first term squared minus that second term squared. And of course, when we square any surd, we're going to end up with a real number, with a rational number. So if I scroll along down here, we did some examples down here in examples E and F. We can see here that when we had 2 plus root 3 multiplied by 2 minus root 3, it ended up giving us an answer of 1. So despite how complicated that might look, we ended up with a rational number. And likewise here, when we had 3 root 5 minus 2 root 3 multiplied by 3 root 5 plus 2 root 3, we ended up with, once again, a rational number. And so that's kind of the clue as to how we're going to work these little devils out. If we find what's called the conjugate, which is, I guess, the other side of the difference of two squares, we can multiply a denominator by that, and we can then end up with a rational number in the bottom of our denominator, in our denominator, which will allow us to continue. So first of all, we just need to get used to this term, the conjugate. The conjugate just means we write the same terms again, so 5 and root 3, but we change the sign. So instead of a minus, that becomes a positive. And likewise on this one, root 2 and 6, let's start by writing what we're supposed to write, root 2 and 6, and I'm going to change that to a negative because that's a positive. And here I'll have root 7, 2, and I'm going to change that minus to a plus, and 3 and root 2, and I'm going to change that minus to a plus. These things aren't equal, they're what's called the conjugate of each other. So basically all that's happened in these little binomials is we've changed the sign in the middle. But that creates that situation that will allow us to rationalise the denominator. So just to go through an example here, if I multiply this by its conjugate, well, what is its conjugate? I know I need 2 and I need root 3. And if I look at that, it's a negative sign, so I'll change that to a positive. Now, 2 plus root 3 divided by 2 plus root 3, that's just 1. It's much like before when we were multiplying by root 2 plus root 2 over root 2. We're just multiplying by essentially a fraction which is equivalent to 1. So we're not changing the value of our surd, but we are expressing it a different way. So if I expand all of that, what I've essentially got, if I multiply the top, 1 times by 2 is 2, 1 times by root 3 is root 3. And then in my denominator, I'm allowed, because I've set this up to be the difference of two squares, remember a plus b times by a minus b is going to give us a squared minus b squared. So that's that first term squared minus the second term squared. So 2 squared is 4, and root 3 squared is just 3. So 4 minus 3 is actually just 1. So we're actually going to end up with the final answer here of 2 plus root 3, because of course any fraction with 1 as the denominator isn't a fraction anymore. So as we have a look at the second example here, I'm going to multiply this. I'll just put a little box around that so it's separate. As I look at this second example here, I'm going to multiply this by the conjugate of 5 plus root 3, which is 5 minus root 3. But obviously, both the top and the bottom get multiplied by 5 minus root 3. So what that's going to leave me with, up the top, I'm going to end up with 5 root 2 as I multiply this number by both terms on the other side. And I'm going to end up with minus root 6, because root 2 times root 3 is root 6. And then down the bottom, I'm going to end up with, well, 5 squared is 25 minus root 3 squared is 3. So I'm going to end up with 5 root 2 minus root 6 on 25 minus 3. Well, that's just 22. Okay. I've got enough time to run through the last couple of examples, which is good. So once again, I have to first pick my conjugate. The conjugate of 2 minus root 2, that's going to be 2 plus root 2. and I just multiply by a fraction with that expression as the numerator and the denominator, because that's equivalent to multiplying by 1. I don't want to change the value of this, I just want to express it in simpler terms. So as I do this, now I've got a binomial, so I'm going to have to, when I look at that top, I'm going to end up with basically 5 plus root 2 multiplied by 2 plus root 2. So I'm going to have to use the claw method. For that, I'll grab my rainbow pen because that's fun, and we'll make our rainbow claw. And there we go. So we use that claw method, we follow the lines on the claw, and that'll tell us what we should end up with. So 5 times 2 is 10. 5 times root 2 is going to be 5 root 2. Root 2 times 2 is 2 root 2. And root 2 times by root 2 is just going to be 2. And I can simplify that to, obviously, I've got some like terms in there. I've got 2 and 10 are like terms, and as well as that, 2 root 2 and 5 root 2 are like terms, so I can simplify that into being 12 plus 7 root 2. So now that I know that that's what's going to happen in the top, I'll jump back into my purple pen. We might throw that in a little box. Don't be afraid to sort of break your question up into little bits like so. Just move that box a bit better so it's not cutting through what I've just done. So now, given I know that's what my top's going to end up with, I'm going to end up with down here is going to equal 12 plus 7 root 2 on, and what happens to our denominator? We square the first one, that's 4, and we square the second. Square of root 2 is just 2, so we're going to end up with 12 plus 7 root 2 on 2, and I can't simplify that because while 12 and 2 have common factors, 7 and 2 do not, so that's as simple as I can make that one. And the final example I'm going to do, I'm going to leave the A's and B's and C's and all that sort of stuff for you guys to have a crack at yourself. The final one I'll do is this one here with 5 plus root 2 as the denominator. So I need to multiply this by 5 minus root 2 over 5 minus root 2. So as I do that, once again I've got a binomial. I won't split this up this time, I'll just run this way. I'll just go root 3 minus 2 multiplied by 5 minus root 2, and it's going to be over, well, 5 squared is 25 and 2 squared is 4. Root 2 squared is 2, my gosh. And I'm going to have to use that claw method to expand my binomial. So let's do that. First, we're going to end up with root 3 times by 5. Well, that's 5 root 3. Root 3 times by root 2. So that's going to, root 3 times by negative root 2. So that's going to be negative root 6. Negative 2 times by negative 5. Negative 2 times by positive 5 is going to be negative 10. Negative 2 times by root 2 is, negative 2 times by negative root 2 is going to be positive 2 root 2. Now, as messy as that looks, that's as simple as that's going to get. I've got no like terms there. I've got something expressed in terms of root 3, something expressed in terms of root 6, and something else expressed in terms of root 2, and then I also have a rational number. I can't simplify that any, so as messy as that looks, that's as clean as it's going to get. And then finally I'm going to end up with 25 minus 2 on the top, so that's going to be 23. And that's it. That's as far as that one can go. So it does look kind of silly to look at this particular thing here and say, well, that is a simplified version of that there. Many people would sort of say, hang on a second, what we started with was a whole lot simpler. But just remember, with regards to simplifying surds, we never leave a surd in the denominator. That has reasons to do with higher level mathematics that you'll deal with later on. It just makes it easier without having those there. Like I said, I was going to leave these particular examples. You can have a crack at those if you want to. Feel free to show me your solutions. But this now is the end of video 3, so at the end of video 3 you can now do questions 13 and 14, and they are worth having a go at. If this, I mean, we don't know what's going on with assessment this year, but in a normal assessment situation you would expect a few questions to do with fractions and surds like these ones in example 1 and example 2, but you're always going to expect some of these questions like example 4 at the harder end of the paper, and it's one of those mathematical skills that if you understand, it's easy to pick up a good 3 or 4 marks towards the back of a paper, which is worth having. So that's the end of that one. As I said, hook into questions 13 and 14, and I look forward to seeing all your happy faces on Zoom tomorrow.